Hey guys, welcome back to Take a Look at Academics. In today's video, I'm going to be teaching you guys how to solve this algebraic equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 5x to the power of 5 minus 5x is equal to 0. Now, the first thing I'm going to do is I'm going to factor out 5. So if I factor out 5, I get 5 times, 5x to the power of 5 divided by 5, that's simply x to the power of 5. And negative 5x divided by 5 is simply negative x. So now this is equal to 0. Now I'm going to divide both sides by 5. So this way, we can just simply get rid of this 5, and it would be much easier to solve this equation. So now, these 5's are both going to cancel out, and 0 divided by 5, that's simply 0. So now I'm left with x to the power of 5 minus x is equal to 0. Now from here, I can go ahead and factor out x. So if I factor out x from here, I get x times x to the power of 4 minus 1 is equal to 0. And now this gives me 2 equations. I have x is equal to 0, and I also have x to the power of 4 minus 1 is equal to 0. So x equals 0, this is already a solution right here, so we already have one solution to our original equation, and we can find our other solutions from this equation. So x to the power of 4 minus 1 equals 0. Well, x to the power of 4, 4 here, this is the same thing as 2 times 2. So if I replace 2 times 2 with 4, I get x to the power of 2 times 2 minus 1 is equal to 0. Now, if I have something in the form a to the power of m times n, we can write this as a to the power of m to the power of n. So x to the power of 2 times 2 is going to be x to the power of 2 to the power of 2. And 1, this is the same thing as 1 squared. So I have minus 1 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is the same thing as a plus b times a minus b. So in this case, a is going to be x squared and b is going to be 1. So now I have x squared plus 1 times x squared minus 1 is equal to 0. So now this gives me 2 equations. I have x squared plus 1 is equal to 0, and I have x squared minus 1 is equal to 0. So let's first start with x squared minus 1 equals 0. I'm going to first add 1 on both sides, and these 2 cancel out, and I'm left with x squared is equal to 1. Now I'm going to be taking the square root on both sides. So then these 2 cancel out, and left with x is equal to the square root of 1, which is actually equal to positive or negative 1. So these are 2 more solutions to our problem. Now for x squared plus 1 equals 0, I'm going to subtract 1 on both sides. So now I have x squared is equal to negative 1. Now if I take the square root on both sides, these 2 cancel out, and I'm left with x is equal to, the square root of negative 1, this is actually equal to I. So now I have x is equal to I. So my solutions are x is equal to 0, 1, negative 1, and I. So these are my 4 solutions to this problem. Alright, so I have x to the power of 3 is equal to x to the power of 5. So now the first thing I'm going to do is I'm going to subtract x to the power of 3 on both sides. So these 2 cancel out, and I'm left with x to the power of 5 minus x to the power of 3 is equal to 0. So now I'm going to factor out x to the power of 3. So now I have x to the power of 3 times x squared minus 1 is equal to 0. So now this is going to give me two equations. I have x to the power of 3 is equal to 0, and I have x squared minus 1 is equal to 0. So for x to the power of 3 equals 0, I'm going to take the cube root on both sides. The cube root of x to the power of 3 is simply x, and the cube root of 0 is 0. So x equals 0 is one solution. Now I have x squared minus 1 equals 0. So now I'm going to add 1 on both sides. So now these two are going to cancel out, and I'll be left with x squared is equal to 1. Now, if I take the square root on both sides, these two cancel out, and I'm left with x is equal to positive or negative 1. So these are two more solutions to our problem. So now, our three solutions to this problem are 0, 1, and negative 1. So now to check, my original equation was x to the power of 3 is equal to x to the power of 5. So let's first check 0. So if x equals 0, I have 0 to the power of 3 is equal to 0 to the power of 5. Now 0 to the power of 3, this is the same thing as 0, and 0 to the power of 5 is the same thing as 0. So 0 works. Now let's try 1. I have x to the power of 3 is equal to x to the power of 5. Now if x is equal to 1, I have 1 to the power of 3 is equal to 1 to the power of 5. 1 to the power of 3 is 1, and 1 to the power of 5 is 1. So this works as well. Now finally, we have negative 1. So I have negative 1 to the power of 3 is equal to negative 1 to the power of 5. Negative 1 to the power of 3 is negative 1. Negative 1 to the power of 5 is negative 1. So this works as well. So these are my three solutions to this problem. All right, so I have 5 to the power of x is equal to 7. Now I want to find the value of x. So for my solution, first start with 5 to the power of x is equal to 7. Now I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 7. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And this property is really important because let's say I have 7 to the power of x is equal to 14. So right now, as you can see, x is really hard to solve for because if x is an exponent, it's going to be really hard to solve for, especially when we know that x is going to be a decimal, because 7 to the power of 1, this is equal to 7, and 7 to the power of 2, this is equal to 49. And 14 is somewhere in between 7 and 49, meaning x is somewhere in between 1 and 2. And solving for this in the form that it is really hard. So now if we change it by taking the log on both sides, now I can move x to the front, and now as you can see, x is a real term, and it's much simpler to solve for it. All I have to do is divide both sides by log 7. So now these two are out, and I have x is equal to log 14 over log 7. So it's actually really simple when you use this property. So now this is what I'm doing for 5 to the power of x is equal to 7. So now I had log 5 to the power of x is equal to log 7. Now I can move x to the front. So now I have x times log 5 is equal to log 7. Now I can go ahead and divide both sides by log 5. So now these two are going to cancel out, and I'm left with x is equal to log 7 over log 5. Now log 7, This is equal to 0.8451, and log 5, this is equal to 0.6990. So now I have 0.8451 over 0.6990, which is equal to approximately 1.2090. So this is my answer. Alright, so in this problem I have m minus n squared is equal to m squared minus n squared. So to solve this problem, I'm going to first start by rewriting m minus n squared. And I'm going to rewrite this to m minus n times m minus n. Now from here, I'm going to expand this by multiplying these two. So to multiply these two, I'm going to first start by distributing the m. M times m is m squared. M times negative n is negative mn. Now I'm going to distribute the negative n. Negative n times m is negative mn. And negative n times negative n is positive n squared. So I have this is equal to m squared minus n squared. Now, I can do a few things here. I can first start by subtracting m squared on both sides, so this way these two m squares cancel out. And now I'll be left with negative mn minus mn plus n squared is equal to negative n squared. Now negative mn minus negative mn is equal to negative 2mn. And then now if I subtract n squared on both sides, these two cancel out and I get negative 2n squared. Now from here, I can divide both sides by negative 2. So then these two negative 2's cancel out, these two negative 2's cancel out, and I'm simply left with mn is equal to n squared. Now from here, I'm going to subtract mn on both sides. So then these two cancel out, and I get n squared minus mn is equal to 0. Now the greatest common factor in n squared minus mn is n. So if I factor out n, I get n times n minus m is equal to 0. So now this gives me two equations. I get n is equal to 0, which is already a solution, and I also get n minus m is equal to 0. Now, going back to our original equation, we have m minus n squared is equal to m squared minus n squared. If n equals 0, I get m minus 0 squared is equal to m squared minus 0 squared, which turns into m squared is equal to m squared, meaning m can really equal any number. If m equals 5, then I have 5 squared is equal to 5 squared. If m equals 100, I get 100 squared is equal to 100 squared. So m can equal any number if n is 0. Now for here, I have n minus m equals 0. So if I add m on both sides, I get n is equal to m. Now, if I put this back into my regular equation, I have m minus n squared is equal to m squared minus n squared, and I'm gonna rewrite n as m because they're both equal to each other. So now I have m minus m squared is equal to m squared minus m squared. M minus m is 0, so I have 0 is equal to 0. And this means that they're both equal to 0. So now going back, what I'm going to do is do a different method to solve this problem. So method 2 is, first let's rewrite the equation. We have m minus n squared is equal to m squared minus n squared. And now this time, I'm going to again expand m minus n squared to m minus n times m minus n. And now from here, I'm going to rewrite m squared minus n squared as m plus n times m minus n. Because if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So now, as you see, we can simply divide both sides by m minus n, cancel these two out. So now I'll be left with m minus n is equal to m plus n. Meaning, if I subtract m on both sides, I get negative n is equal to positive n. If I add n on both sides, I get 2n is equal to 0, meaning n is also equal to 0. And if n equals 0, then remember how we already tried this out, m is also equal to 0. So these are my two solutions to this equation.